What's going on? I just finished my OA. In case you didn't think I was a savage, I did it in high school despite it making me lose points. But I got, I think I can share this. Where do you paste an image to? Okay, yeah. I got, to be fair, this was freaking hella easy. The last problem I messed up because I couldn't sort my Pascal sort map type. I was trying to sort. Frick. Huh. Yeah, there was literally fizz buzz on this, bruh. He got me fucked up. Wait, is this on? Do mic check. Wait, I forgot I'm supposed to not be saying like. I already know I said like. But okay. So yeah, that's fine. So yeah, question one. What was question one, bruh? I guess you probably shouldn't talk too much about the questions, even though I have 0 viewers. But it was all free. I think if I was in like Python or something, I could have got number 5. But I couldn't sort my map. I used data. Yeah, I was using. That was really dumb, actually. I was using data.list sort to sort. I had a map.map. So how do you sort a map? This guy's going map. I'm not from list, like to list. Map from list, data list, sort. Another problem is that my types weren't right, so I just deleted my type signatures to make it work. Oh yeah, that's what I was trying to do. Map. I should use qualified. Yeah, I had like a massive list of all the things I was trying to get. That makes sense. Map from keys to values A. So I had a map of arrays to averages. And I was trying to sort them by their averages. Yeah, I didn't understand what I was trying to do there, but whatever. Okay, so what am I gonna do right now? That's that way recap. If that's not good enough, bruh. Come on, bruh. Give me a Haskell handicap. You gotta respect it. So it's a lost art. Got some homeworks graded. Hope I didn't get murked. Okay. I gotta start studying for finals and grad. All right. So I gotta work on this FPGA shite. It's kind of annoying because I joined this club. Like, if I was gonna be solo queuing this, if anyone was gonna be solo queuing this whole thing, I wouldn't have done it. So I might just try to simplify it. Alright, so what do I want to get out of this? Because at this point, it's mostly an exercise. Um, hmm, damn it, bro. I joined this club because I was like, this is like one of the sweatiest clubs. Like, I bet I'll learn something. I didn't really want to end up leading something. That's just how it happens, I guess. I'm trying to think, like, basically, like, I joined, dude, oh, I just said like way too many times. Alright, let me start being more intentional with it. So I joined the trading club because I know they have hard, like, trading has, like, oh my, trading has hard, as in complex systems problems, unlike other clubs. For instance, I was in the web dev club for 3 semesters, and it's just a bit easy? Easy in that you're really just building the thing. It doesn't require any real knowledge or growth, honestly. You just define the project and make it. At least that was the point I was at, particularly with like, I mean, these projects are CRUD apps with a front end. So once you know how to use your frameworks, the implementation is free. And I think trading, that's not the case. And that was particularly interesting to me because you can't, just given that everything is like given that everything is essentially an optimization problem, and it's also directly competitive, it's hence more technical and more interesting. So I joined this club a bit for that, and also because I'm only going to be in college 1 more year. I can work on open source stuff by myself, as I'm doing with, not even by myself, like I'm doing with Request and Gripe, but also within bigger online communities, like programming languages and such. I'll always be able to do that, but I only have a few more semesters where I can meet people in person who are interested in working on a project. And that was the main appeal to me, is this club is like a, this club is a application club, as in you have to get into it. And I thought it would be, it is, but I didn't get into it as a problem. People care. Not only do people care about the thing, but it's also people are just better at programming. I don't really care to do a project that's a tutorial. I want to actually make something useful that actually teaches you something, which I thought was very much so the case in this club. But I ended up doing this FPGA project, and it's nice and it's cool. But by the time I'm doing everything by myself, I'd rather just be working on the stuff that I had been working on anyways. So yeah. So I imagine I probably won't do this next semester, honestly. Just because, like, I'm not a trader. I'm not trying to be some finance quant guy. Um, yeah, so. What do I want to get out of this? This is like the question I was trying to answer with that. Um, hmm. I want to get out of this. So I want to have a good presentation. And that implies that something works. It would be nice to know what goes into writing a big hardware project with IP cores, custom cores, perhaps an open source core in there. building it, setting up constraints, generating bitstream, setting up verilator tests and all that. That's just involved in building the project. It would be nice to have like a consistent project. I'm gonna pass that one. It would be nice to have a consistent project that I work on over a long period of time, which I think is what I'm building in Gleam and Request, some other projects. But would this be one of them? I don't know. I do think this is the type of thing that if it works, it is like quite popular, especially that there's not that many. Like this is a popular domain, but not a lot of people are actually writing open source software, at least on the hardware side. It's because it's not software, but it's not common for people to work on this, but it's common for people to talk about it and know that it exists. But I'm not really too concerned about just farming stars. I'm counting the overview contributing. So, I have a week to work on this. So until next, when are my finals? Yeah. So today is воскресенье. This entire week, I have, let's say 10 hours of homework. Then I have my multi-final and my bio final. So I'll cut it off on the 2nd. So let's say I have 7 days. I have around, I'll say 50 hours to put in this project. 50 hours. So what can I get done in 50 hours? Let's reserve 6 hours for the presentation. What can I get in 44 hours? Can I set up networking? The thing is, a lot of these I haven't done before, nor have many people, that, at least those that publish online, that they would say that they've done it. So the upper bound for the amount of time it takes some of these things is literally billions of hours. So, it may be smart. So either way, we're trying to think. I want some interaction to be on the FPGA. The easiest of these to implement on the FPGA that's actually related to trading is the accumulators. So either way, whether or not the TCP IP, or in our new case, UDP stack is on the FPGA or not, whether or not the request builder and all these other things are on the FPGA or not, we need to be able to DMA from the host to the FPGA. So either way, I'll need to fledge out the DMA lib, and that'll also be a nice exercise in programming C. So that's something that needs to be done. So that makes sense. So if I do the DMA lib, let's say that takes 20 hours. Perhaps plus or minus 10 hours. If it's more on the minus side, I can perhaps consider doing some networking stuff there. If it's more on the plus side, I will do the UDP and such software, and then DMA onto the FPGA for the implementation of the moving average accumulators. Okay. So either way, I need to be able to DMA onto the FPGA and do what? I need to look at this. I need to be able to pass data into the accumulators and grab the values out of the accumulators. So you can designate some registers for these. So we should probably map the memory on the host. The host memory. We'll have some registers that do things. So let's write a program that just allows let's say the switches or something, or any value, any constant, just anything. Let's just write DMA. So that's kind of difficult and proprietary to the FPGA. So I don't want to look too much into the IP. It's also just so impossible to read. Probably just look up how to do it. So let's just look up FPGA DMA. No, we're working on a DMA library. Actually, we got, and like, it's working. All right, so I'll probably sit here. Scheiße. Be here for a few hours. Here for like 6 hours. So PCIe Express DMA drivers and software. Sounds quite nice. So I think I have a 7 series. Gen 2. Do one extra drivers and software. Windows, so I don't want that, I want this. I want Linux driver files. So these are the IP drivers. Linux kernel, XDMA, QDMA. So what do I need? So QDMA, XDMA, XVSec. So I'm not sure which of these I need. So QDMA, Linux kernel. What is QDMA? So what is the difference in QDMA, XDMA, and XVSec? QDMA, so imagine it's just QDMA and XDMA. So is this a feature of my FPGA or something else? DMA, share DMA engines. Are they both usable? So I'm gonna pull up my IP. Looking at IP. It's kind of humorous though. So let's see. So I'm trying to see what. I might also break this up with some reading. I need to finish some books. Ah, scheiße. So I'm not getting off until it's either my bedtime or DMA works. Or probably a plot. It's a good one. Okay. But first, maybe I should queue up a laundry. That's sad. It's Saturday. That's gonna be freaking impossible. Let me just get some bed. Let me get a bed. Yeah. Unfortunately, we were just stuck drinking last night's water. Alright, so what's the difference in XDMA and QDMA? Alright, so let me go to IP. I was on IP the whole time. So let me open up my thing and look what it says. Я хочу что-то слышать. Музыку. Давайте... Что я... Что в основном? Работать? Я не это вижу. It looks quite low on the frequency band though. Or the volume band. It's also because my amp is super loud. So. Could be the user manual. Control F that. DMA. No entries. Oh, never mind, there's some entries. Appeared to be some entries. So the PCIe interface, so we have these pins. Alright, so I should probably go ahead and make my constraint. So, it's probably a Jippity mini question. So we're going to cd punt clear env dot shift tab constraints. I'm gonna add constraints dot, what's the file type? XDC, meaning we can delete the get keep. So we're gonna have our PCIe, PCIe. So I believe this is fine to open. So here's the board manual. Alright, so this is also called DMA. Nature Y. So this is the dev board. So it's talking about the DRAM. So here's our DRAM. And we have our DRAM pins. So those are open as well. So I can have these two open. I think this is what I can have open, the Dropbox. So looking for, or what's the other one? That is the AX7103 docs, in contrast with the user manual. So I'm looking for DMA. There is a PCIe speed test. This is referencing XDMA. So I believe I need the XDMA drivers. So we need the XDMA IP. Set up the DMA bridge subsystem for PCI Express. PCI D bars set as follows: AXI light. 2, we're gonna get the date gen, so that's just testing. HDL wrapper it. Experiment phenomena. Just some old head Windows 7. Either way. And he's going into the waveform editor, showing some shite in Chinese. So I'm probably fucked in that respect. Let's see. Alright, so I can pin that. I can open all of this. Yeah. This is fine. This is fine. Pin that. Pin that. Pin that. Close this. Okay, so let's go back to stream. Bro, I'm going downstairs. I kind of want to get some. Yeah, I'm getting a sody pop, bro. Get a little sody pop. Segundo. I got root out of my rosemary plant, and I'm blaming Kroger. It's tough. It's probably never recovered. PB extra cupil. PB extra. PB. I honestly might just copy paste the drivers. I don't really know. I've never like manually installed Linux drivers. I'm a normie using a distribution. Maybe one of these days I'll do a self-rolled Linux. I don't know. I'm like kind of getting into Linux with the Linux kernel development book. It's kind of crazy how like I don't know, like even as somebody programming for a while, like I mean I just finished like the systems architecture book, which like largely had to do with operating systems, just like I know I just said like 2 times there. Fuck me, dude. Just the breadth of a project like Linux is just insane. It's kind of crazy that that can even exist, but it does, and it's better than Windows. It is also kind of crazy how Windows exists. Like dudes just get hired to work on Windows OS. Who works on Windows? Oh my god, dude, I'm talking about an operating system, not actual Windows, bro. So yeah, but what person? I'm curious what the development cycle is for Windows. People. What? Okay, people just... No, I'm literally the only person on the map with that question. Alright, so in the constraints... so we have these pin numbers. So this has the... So that's SD card. There's PCIe. PCIe X4 on the carrier board is here. And on this, we'll have the DDR3. And our clock. So his clock is on R4 or T4? Let's probably copy that out somewhere. It's a differential pair. So I should look at... I had before a project. I'm gonna go back to IP mode so I can look at how they did it for my FPGA. I'm gonna pass that on. So looking into this Dropbox. The Dropbox has a bunch of example projects, but they're all from like '08, effectively. I can just imagine some like random 60-year-old Chinese dude running Windows XP. That's actually insane at what he does, but confusing to an end user like me. Just grinding out of these projects. What was I just about to do? CD temp. I need to clear my temp out. What about FPGA You have constraints. So this is synth straight from Xilinx, interestingly. It's a bit suspicious. Let's do RAM user bypass, CD RAM user bypass, and constraint. No constraint. XTC. So there's a clock domain. ACLK. Let me search grep for like what would be in the constraint file. set underscore property. So we have a lot of TCLs. What's the pin of the clock? So in the PCI project, there would have to be PCI RX0P. PCIe underscore RX0 RX. So there's a ton of Verilog in here. I got a bunch of parameters. So this is Xilinx IP. Series 7 integrated PCIe block. I don't know, this one's kind of crazy though. Circus extended. Oh, this one's nice. So there's the transmit and the receive pair. So I'm gonna just trust this thing. I'm not really seeing constraints. It might not be that simple when you get into a bigger project. I remember doing one that's literally just a switch. Let me exit. Alright, so we're just gonna close the IP. And we're gonna go back. Alright. So I'm looking at this, right? We have these PCI pins. So since I'm lazy, oh, it's not gonna be able to read that, is it? So on the PCIe bus, you have TX and RX. So PCIe explained. Looking at the architecture. So I'm curious as to what is this TX and RX? TX, RTX, RTX. So is that RX? Is that where they're getting that from? RX and TX? So that's not immediately useful. PCIe, how does PCIe work? Peripheral component interconnect express. It goes from X1 to X16. I think I'm on X2. What is the X main? Maybe this is X4. Okay, it is X4. So that means it's 4 bits at a time. Then you have RX and you have TX. Does it explain what that is in here? The differential signal mode. The single channel communication rate can be as high as 5 gigabit. 5 gigabit? Ref clock 100 megahertz. Excuse me. We also have these Ethernet pin assignments. So we'll probably need all of these. So how does it work? So we just read about this yesterday. Application transport. So here's the RX and TX. Transmitter and receiver. PCI link is established. Application layer facilitates data transfer. Corresponding device driver generates PCIe traffic which traverses from the translation. transaction to the data link, and then to the physical. Finally to the opposite side of the link. Need some lotion, bro. I need a better way to clean my glasses as well, besides just rubbing them on the same towel I've wiped them off the past 2 years. Oh. So you have transmitter and receiver. Corresponding device driver generates PCIe traffic, which traverses from the transaction to the data link. The physical. I don't think I have PCIe 7.0. So, transmitter and receiver. So you kind of just imagine. Oh, and this is the case for the Ethernet as well. So that's a global thing. So I believe I need XDMA. This was mentioned. So Linux kernel. This is for x86. Kernel 310 above. Effectively on Red Hat Enterprise. PCDMA, please refer to it as XDMA. PCIe driver files. That's the driver. Use it, so cd install make mod probe. So we're gonna need that. Might be nice to do my pin assignments first. So I'm curious. So I'm running a big project. 2 ETH ports, PCIe, RAM, should all can. Also my pin numbers. Alright, yeah, I agree, should split it up. We're gonna have constraints, so let's make this an issue on GitHub. Make a new issue. Wrong repo. All contingent. Issues. Decrease pipelining. So let's make a new one. Milestone. Is there a good milestone? We can go with Vivado. Intention projects. Labels. So this is an enhancement. Go ahead and sign myself. This is setup pin constraints. Constraints for all. FD docs to get constraints in the constraints file. Clocks, ETH1 and 2, PCIe, DRAM. We can make this in progress. So, like Jippity said, I think it's good to have constraints general. XDC? I've never heard of this. This one's to be PCIe. It's modified. Nah. Sure. PCIe. Okay, so now there's an LSP going on. So I don't really need the PCIe comment anymore. CDD WD. So that's good. Ignore the create project. You have generally a PCIe constraints. DRAM.xdc constraints. DRAM constraints ETH constraints ETH1.xdc constraints ETH2.xdc. So these are the clocks and such. ETH1, ETH2, DRAM, PCIe. All right. So anyway, PCIe data sheets. So where's the variable in this? Price M15, L15. Okay. PCIe. So set property package pin N14. Clock P. Okay, so this is here. See nothing about a clock. Sure. I do see something with a clock. That's F10. F10. Clock P. Clock N. So that is E10. So this is a clock constant. So there's data reception, data transmission. So this is reception. So let's do this. Data reception. So RxP, Rx0P, Rxn, 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 Rxn. So we're gonna have more of these. PCIe, Rx0P. has 3 channels. Both RX and TX. So it's going in each lane by lanes. Control signals in the wake. So I'll copy their setup. Reference clock. Huh? PCA interface constraints 4 lane. Reference clock. So you got clock P, clock N, whatever that is, and you got this reference control pairs. So you got TX0, TX1. Just to keep things brief, TX2, TX3. And after that, we're going to have receive. So X0, X1, 2, X3. For control signals, so does it have a reset? I'm not seeing a reset. I don't think it has a reset. So it doesn't have a reset nor a wake. So TX0. So TX0P. Package pin. So I'm looking for D5. PCIe TXP0. So our syntax is TX0P. TX0P. TX0 and 0. Oh, there's probably a macro to do this. TX0 and 0 and TX0 and TX0 and TX0 and. So the N port pin C5. PCI 3.0. Is it PCI 3.0? PCIe X4? Not sure if that's right. So, so we do a percent s slash tx underscore p. Okay, so what are we going to do? This macro should move this. So we're going to do Q. We're going to put this in the A register. So we're going to go to the beginning next instance of x underscore. We're going to go enter. We're going to go next. And then we're going to go to the right. A. We're gonna get out. We're gonna X the number. Back P. We're gonna Q. A. So we're gonna go at A. So 20 at A. X2N, is that right? X2N. X2N, so also let's just do 100 at A. So I think we did it. That's why I'm the GOAT. TX0P, TX0P, TX0N, TX0N, TX0P, PCE underscore TX0 underscore P. And then for TX1, you got B4, A4. Yeah, D5, C5, B4, A4, B6, A6. B6, A6, D7, C7. C7 here. Scheisse. C7. And then for the receive, D11, C11. D11, C11. Then we got B8, A8. Then we got B10, A10. We got D9, C9. D9 and C9. Right? D9, C9, then SD5, D5. Okay, so I think that's right. So we're just gonna act like that's right. I think that's right. Oh. There's that. What else did it do? So next. Ground. Yeah, I'm not sure I need that. So this is looking at RAM. Not sure what. Whoa. What sparked this message here? There's PCIe goes to ETH1. Seems relatively reasonable. Where's my ETH at? Where's my ETH at, man? So we got some signals here. So looking at the ref clock. So the pins are named E1, TXT3, TXT0. Hopefully it understands that. This might be the best use of Jibbity, is just formatting strings. Oh. Press DOT with the actual pin. That's because I missed him. B22. E2 media, C22. See, it's kind of smart. It's kind of smart with it. Because it knew to ask me. Because, like, I wouldn't have caught that. but it didn't come out that. So good job, Jivity. System clock. Is that a thing? Ground and is there a global ground and a global? Oh wait, PCIe Gen 2. PCIe Gen 2. PCIe is Gen 2 4X. Excuse me. So what is this PCIe 3.0 in that case? ETH2, so I'm not sure why it's sending that again. Looks like it's changing the period in here. Set at 0.125 once period 10.0. Huh. Okay, so that works allegedly. So LVC must. So this is on the ETH. So LVCMOS. Let's go to the ETH. This is the DDR3. Back to my ETH. Where's my ETH at? In the wrong document, homie. The ETH. They're from the jail semi. Communicate with the MAC layer of the RGMI 2. So this is the G5 chip. So I should probably connect my PHY chip. So I don't know much about the PHY. Not sure if we need constraints. MDI, MX, master slave, MDIO bus. What is this called? Look over. Yes, we're running a DMA web. So we do need constraints. So in ETH1, it's changing a bit. Just blindly copy this because why not? So PHY address. So the PHY pin, configuration pin, adder 1, adder 2. So what's the pin? Wait, so what is the pin number? So this. The PHY, what does the PHY do? Board to board connector, power supply, GT3, 2 crystals, FPGA chip. That is a good question. What are the, so you have configuration pin. LEDs, you have the MDI, 2 LEDs. RX, PHY address. I think that's what it's, I think that's right, I don't know. There's 0 pin. RX3 adder 1. 3 adder 2. E1 reset. PHY chip reset. PHY chip reset. So he's got connected. So this is the PHY. This must be IP. U1 and U2. JL2121. JL2121 E5. RIP. That's not what I asked, bro. DDR3 clock. So hopefully this is correct. BGP. So let's look at it. Clock positive R3, clock negative R2. Pair properties PN, diff term true. So DQS. So that is the differential pair property. Differential data strobe. You got E1, D1. That's 0. Then you got K2, J2. You got M1, L1. Then you got P5, P4. Then you got all of this. So you just gotta spam these. So 1. It's gonna be G1. Two. It's gonna be A1. 3. F3. Bro, why is it making me do this? I just told it to do it. Why is the LOM lazy, bro? It doesn't take you any time to do it. Okay. Oh wait, it does that for every pin. It's got to do the slew fast for every single one. That's really aids. Yeah, that would take approximately 40 hours. Is it just DQ? No, then it's A. Then it's all the A's. Hey, it's doing the A's. So let's do this, P. So then it's going to do the A's. So for the A's. So DDR3 ORT? What is that? DDR3 SICKY? I don't have that, bro. DDR3 ROS and COS? ROS is V4. Sorry, this is W4. This is V4. Write enables AA1. Reset. It's W6. Is it just all false? So reset. W6. Write enable AA1. ROS. V4. COS. W4. So the bank addresses, there's 3 of them. So So you got AA3. So these are just all incorrect. That's awesome. So you got AA3. BA1 is Y3. You got Y4. And this is for BA2. There's your bank address. So the address V3. So I think it's off by 1. U1, V3, Y3, 14. So it's a 15-bit address. A14 is V3. 13, U1. 12, Y2. 11, W2. So yeah, it's just a straight up random, pseudo random. 10, Y1. 9, U2, V2, T1, W1, U3, AB1, AB5, AA5, A4, 1 is AB2, 2, A5, 3, AB5, 4, AB1, U3, W1, T1, V2, U2, Y1, W2, W2, Y2, U1, V3, AA3, Y3, Y4, W4. So we have an S0. It's nowhere to be found. We have W4 for cos, V4 for Ros, A1 for right enable. Wait, so I think I accidentally deleted what it said I actually needed. ODT I have. CKE I have as well, I'm just tripping. So I have both of these. So this one was CKE, it's T5. DDR3 out. Sorry, ODT is U5. What about S0? Let's do one after BA. DDR3 underscore S0. AB3. There's S0, so there's that. In general. So I think general has like the clock. Alright, that should be everything. So, well, that's unusable. Did I get a copyright strike yet? Oh no, 0 viewers, copyright strike. Did I get a copyright strike yet? Notificacja. So I give somebody the opportunity to get an easy contribution by clicking a button if they want it. Though I'll probably end up self-merging that in a minute. Até Jason. Alright, I'm going to the bathroom. Até Mr. Yuko. There. Ooh, bruh. did the pin constraints, but did I actually, I don't know, that's not actually doing anything. It doesn't even confirm to work either. I need to like do something, write something that actually does something. Okay, put this in the fridge. Some water. See it, bro? Good. Now keep it rolling. I'm doing. All right. So no IP, am I? Let's go back to this. Look, I had that on for a while. I had it on for 5 minutes. Huh. Somebody watch this for 12 seconds. Thank you. So I have this open. I'm really just begging somebody to approve this so they can have a chance of doing something. But either way, I'll just stack diff here. Can stack gifs? Stacked diff. GitHub. GitHub. Yeah, this is cool. Why does it have to do with AI? What does stack diffs have to do with AI, bro? Why does everything have to be AI? Yeah, but. So I believe this is the part number. So do I have that part? The file's part part name. So what is the part name? I'm unsure. So read XDC. Constraint files at the top module. Save project into project name XPR. Project name Pont Engine. Part name. Part number. On top. So the top module. So you need to run it in this directory. Hmm. Yeah, that comment on there. Not sure that's even relevant, but do it. So let's get switch main. Full Q. So I gave dudes a chance to hop on and do this. I'm gonna disable auto merge, squash and merge. Delete the branch. There's a lot of TCO. Interestingly. So that makes sense though. What does get attributes have? Linguist rendered. Oh yeah, that undoes it. So this is gonna be the easiest issue yet. I just gotta make some gimme issues. If that doesn't get done, like, I really don't know what to tell you. We're gonna pause and read a chapter of the Verilog book. So if that on page like 600 or something. It goes this chapter 500. Chapter is this? Field programming gateways. FPGAs in the ASIC market. 400. Alright, so let's go to 0. Let's go to 1. What are the chapters? Trying to figure out where I left off at. We gotta like fix some skill list of primitives. Too far. Control value by cyclic behavior before it is referenced. So I think I'm on chapter 7. .347 to 415. Let's read some chapters of this. That's offset. Plus 26, 347, 26. Was it not off by 26? Design and synthesis of datapath controllers. I'm gonna edit the title of this. I need a DMA library for FPGA. Reading barrel. Datapath design. In a way, somebody actually watched this. Yobo say yo. What does Yobo mean? Korean. Hi. I never considered the case where somebody would voluntarily watch this. But yeah, shout out Mike BG Squad. So if you're in the mood to be like further bored, I'm about to start reading this chapter of this book on the design and synthesis of data path controllers. This is like an advanced Verilog book. And after that, I'll get back to using the pin assignments I just made to try and write something that uses DMA, particularly XDMA on or via PCIe. But first, I'm trying to like just incrementally chip away at this book. And so, I'm about to contribute to that by reading this. So you have control-dominated and data-dominated systems. This is definitely a data-dominated system. Most data paths include ALUs. That's like our moving average accumulators. Graphics coprocessors don't. Data path units consist of computational resources. You can model data paths as finite state machines, coordinating the execution of instructions that perform operations. Partitioned sequential machines. Partitioning a sequential machine into a data path and a controller clarifies the architecture and simplifies the design of the system. The process by which the machine is designed is said to be application-driven, because the sequence of operations that must be performed by the data path unit in a particular application determines the resources composing its architecture. The set of instructions that must be... So this is a list here. The set of instructions that must be executed by the data path and ultimately the FSM controls it. So we have a data path, clocking, some data path registers. There's some sequential logic that is generating some status signals. These are transitions on a finite state machine that imply successive control signals. Perhaps, like, definitely influenced by external control outputs that are plugged into the finite state machine. So, control units orchestrate the operations. You can use data flow graphs. Did I already read this? I think I read this. Yeah, I think I actually already read this. Got the Moxie. Yeah, I definitely read this. Live. Was it on live? Basic computer networking and hardware UDP handlers. That was yesterday. I haven't read this in. So yeah, I'm gonna assume I'm on chapter 8. Because I think I already read this. So chapter 8. $4.15. So we got programmable logic and storage devices. So it's left by 26. Embarrassing. Alright, false alarm, I'm reading this one. As technology advances, the density, complexity, and size of FPGAs provide an attractive, cost-efficient, and increasingly important alternative to semi-custom application-specific integrated circuits. They're expensive. Large circuits in FPGAs warrant their use. Sounds like a great chapter. Emphasizing a design flow for FPGAs that is entirely Verilog based. So ROMs, POAs, PALs. Couldn't tell you the difference. Complex PODs, FPGAs, mask programmable gate arrays. We use the term PLD. programmable logic device to indicate the low density structures that were introduced to implement two low level logics. Distinguished by having a regular structure. So, ROMs. So, I don't think I'm too concerned. Programmable logic devices have a fixed architecture. So, field programmable logic devices. It can be manufactured. So yeah, my goal with this book is to be a better developer for what I'm developing. So I don't think this is too relevant. Architecture used to implement PODs lends itself to different storage devices. Read-only memory, random access memory. You have inputs on an AND plane, product turns on an OR plane. You have outputs. So I know what ROM is. You decode an address. You have a mask program to pull down transistor link. I don't know how this works, nor do I care. This is not really my level here. Circuit structure of a mask program and MOS ROM. So, non-volatile memory, because the stored information remains when a power is removed from the device. A programmable ROM is one that can be programmed by an end user. Erasable ROMs. ROM-based implementation of combinational logic. So I'll read this. They're good for truth tables. 2 to the 2 to the n different functions of n inputs. Single ROM can implement any of these functions at any of its bit lines. You could just replace the ROM. Complexity of the logic being implemented does not have an input on the effort of the program device. Use discrete or block-based logic. Often faster than FPGAs. Usually more expensive for the circuitry. Verilog system tasks for the ROMs. Verilog has 2 file input-output system tasks that can be used to load memory data from a text file. Okay. So you don't have to write the words, you can just load the bytes. Single ROM model can serve as a variety of applications. Can serve a variety of applications by substituting text files. The tasks readmemb and readmemh load to specified locations in a memory the contents of a text file formatted as binary or hexadecimal words. So we have an example here. So this is good to know. So we have a truth table of a 2-bit comparator. And you can use initial readmemb with the file path ROM 015. Representing this truth table. So it's expecting it to be in the same folder in which the project is located unless you specify a different path name. ROM-based state machines. So, I have some experience with ROMs. Writing like microcode. Like the implementation of assembly instructions with the ROMs. So that's really all I care to understand. Some of this also sounds a bit old. It's got a mealy state machine. He's filling his ROM with some don't cares. And then the reverse direction. flash memory. Not too compelled to read that. Nor that. Tired, bro. Oh yeah, Loki just fell asleep. It's kind of funny. Nah, I should just freaking fell asleep, dude. Reading, 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 reading. Asleep. Nah, that's how we're done, bro. Bruh. Nah, that's how we're done, bro. That's bro, it's such a snoozer, bro. All right, so now that I'm awake, so this is running RAM. I don't really care about that. Сегодня воскресенье. Yep. So we're just gonna skip to the FPGA's part. Like, so I'll read the field programmable gate arrays thing. You guys good? Okay. Constraints. Yeah, it's supposed to be constraints. That's my bad. I'm a little dumb type. All right. So register-rich tiled architecture. Nah, I just got caught sleeping on live, bro. That's so not it. So I know what an FPGA is. Resources. Interconnects between functional units. I'm goaded. And they're connected by interconnects in an array-like manner. FPGAs are not ASICs, and vice versa. There's a Discord for 10 years. Rough round there. But... So, mass program gate arrays can only be programmed once. Anti-fuse, EPROM, SRAM based. So I think mine is SRAM. Now we're talking about the Altera Flex 8000s. So you have this embedded array of logic elements and logic array blocks. Column interconnects containing I/O elements. Map it between them. So I've got these thingies. So this is interesting. So a logic element. Clock select, lookup table with carry chain. Cascade chain, register bypass. Interconnects, programmable register. Logic. To AND the outputs to form a function of more than 4 variables, or to OR the outputs, which forms the sum of cubes. So you can support dual clock applications like FIFOs. Cascaded chains, select bits, map them to lookup tables, and them together. Shows comparing some attributes of them. The Apex FPGAs. Product term integration for high-speed logic control logic. So, Xilinx. These have a switch matrix. Switch matrix connected by, there's I/O buffers on the outside, configurable logic blocks on the inside, interconnects with switch matrices, controlling them. So here is a COB. You have two functions, some multiplexers, DN, F prime, G prime, H prime, and you have two outputs. Distributed RAM. So good to know. I don't think this changes much for me. IO block. RAM cell. Pip within a switch box. Single ported RAM from a LET. I don't really care about this. So IP cores for system on a chip. Embedding an FPGA within an ASIC. That's interesting. Finally, the part I wanted to read is 2 paragraphs. Let's go. That's real. It is recommended that all of the register variables that are assigned value with a level sensitive cycle behavior be initialized at the beginning of the OSD code, and then assign value within the behavior by exception, as a way to prevent synthesis of unwanted latches. The registers in the COB do not power up on a specific state. They do not power up to a specific state, so you have to have a good reset. Decoding logic should be implemented with case rather than if then else. It's parallel logic. If then else is nested logic. Improve throughput by partitioning combinational logic systematically and unsorting registers at the interface between the partitions. Pipeline registers occupy CLPs. We're talking about more, so this is kind of foundational. We're talking about pipelining more in chapter 9, which is what I'm trying to get to. One hop encoding. Good point. Did I just skip into the chapter? Or is this an example? Wait, what did I just skip to? I just finished chapter 8, right? Just read that, 415. Yeah, that was a ton of problems. Oh, 457 is such a good chapter. No, this is like what I needed right here. Accumulators, differentiators, pipelined architecture, circular buffers, FIFOs, and synchronization across clock domains. 547. Good. Three hours. No, the whole 20-minute nap makes it feel like a long time. What do I call it? Study. Writing FPGA DMA whip, studying datapath design, reading on hardware algorithms. Alright, so I'm gonna read this one. Kind of in the mood to stand up, you know what I mean? What can I do right now? So it's just grind this. Шестьдесят девять. Интересно. Let me do this. Got rejected. Google Drive. Cleric. And JP Morgan Chase. Recent. Jobs X 2025. Cleric. Control F. Cleric. Rejected. Twitch ditto A. And JP. What? I got 100 on the OA and you rejected me? Bro. That's insane. Actually trolling, dude. What are you gonna give me the OA for if I get 100 and you don't accept me, bro? You're wasting my time. Cycle I've applied to 123. 40 rejections, 8 OAs, 1 interview, 0 offer. Damn. So 1 hot encoding. So I'm gonna read this one on the algorithms. Yeah, I just wanna like walk. I just wanna like walk around. I've been sitting for like 30 years. Let me just keep it on this. Let me just act like I'm going to the bathroom. Actually, we're just gonna end this, and I'll do the algorithms one later. Just a little buffer.